Hey everybody, Mr. Reeves back with you today, and today we're looking at multiplying rational numbers. All right, so we have been talking about what rational numbers are. Again, a rational number is any number that can be written as a fraction a over b, where a and b are integers and b is not equal to 0. We've been looking at rational numbers in three different forms: as fractions, as decimals, and as mixed numbers. All right. And of course, most recently, we have been adding and subtracting those rational numbers. Today, we're going to look at multiplying rational numbers. And we're going to be looking at them with different signs. So we did multiplying numbers with different signs when we did integers. Remember, an integer is a whole number, or the opposite of a whole number. So now the only difference is we're going to have fractions, and we're going to have decimals, and we're going to have mixed numbers. But the rules are the same as far as the signs go. So let's do a quick review of what those rules are. Remember, product is the answer to a multiplication problem. So when you are multiplying numbers, whether they are integers, whether they are rational numbers, or real numbers actually, any type, a positive times a negative will be a negative, and a negative times a positive will be a negative. So if you only have two factors, if the factors have different signs, the answer will be negative. And of course, if you only have two factors and the signs are the same, then that means the answer will be positive. So a positive times a positive is a positive, and a negative times a negative is a negative. All right, so there is something else we should look at, because you're not always going to be limited to just two factors, are you? So let's go ahead and pull up some paper here. So again, a negative times a negative is going to be a positive. A positive times a positive is going to be a positive. A negative times a positive is going to be a negative. And a positive times a negative is going to be a negative. So that takes care of if there are two factors, right? All right, but what if there are more than two factors? So let me go ahead and write this. Two factors. What if there are more than two factors? If you have more than two factors, then we're going to use the fact that every time you have a negative times a negative, you get a positive. So if the number of factors is even, if the number of factors is even, all right, then the product is positive, okay? If the number of factors is even, then the product is positive, because if you think about it, every two negatives is going to make a positive when you multiply. So even means it could be divided by 2. That's times there. So if it's even, then you could pair them all up and you will always get a positive answer, all right? Conversely, or inversely, if the number of factors is odd, then the product will be negative. Because if it is odd, this is what's going to happen. You're going to pair off the pairs, right? But if it's odd, you're always going to have one left over, right? And that's going to make it negative. Okay, so if you have two factors, here are your rules right here. If you have more than two factors, here are your rules right here. It's pretty straightforward. Even number is going to be positive because you're breaking them up into pairs, which will always be positive. Odd number, it will be negative because you're breaking them up into pairs, but you'll still have that one odd negative, which will make it negative. Okay, so those are the rules for the sign. All right, so sign of product rules. Okay. All right, now why is that the case? All right, just back a reminder, and they say right here, you can use the fact that multiplication is repeated addition. All right, now I'm gonna amend this a little bit. I'm gonna say multiplication of a positive number is repeated addition. All right, is repeated addition. And then I'm going to say multiplicate, not off, Mr. Reeves, of. There's only one F. Come on, eraser. Come on, eraser. Here we go. Multiplication of a positive number is repeated addition, okay? Multiplication of a negative number can be thought of as repeated subtraction. I'm going to run out of room. I can tell here. I'm going to do this. Is repeated subtraction. Okay? So, again, before we had negative numbers, it was clear. Multiplication was repeated addition. 2 times 7 is either 7 plus 7, 2 sevens, or 7 twos. 2 plus 2 plus 2 plus 2, 7 times, okay? Multiplication of a negative number is repeated subtraction, all right? So we're going to repeatedly subtract the number instead of repeatedly adding the number, all right? So that is something to keep in mind as well. All right, so let's take a look at some of the problems they have here. They are going to ask you to look on a number line. So let's just take a look right here. We have 4 times a negative a half. So since 4 is positive, this is going to be repeatedly adding a negative a half. So you could see negative a half, negative a half, negative a half, negative a half. 4 negative halves make negative 4 halves, which is negative 2, right? So if we were to take a look on this number line right here, 2 times negative 3.5. So we're going to go ahead and start at 0 because we always start at 0. Let me get this out of the way. So there is negative 3.5. So that's 1 negative 3.5. Sorry, that went a little crooked. And then 2 negative 3.5s is going to put me at negative 7, right? Because right here again is negative 3.5. And then if I went another negative 3.5, that would put me at negative 7, okay? So negative 7. Positive times a negative is a negative. 2 negative 3.5s got me to negative 7. So that's an example of doing it on the number line. Okay, now, what we're going to have here is we have a little problem. Now, we know a negative times a negative is a positive. So we should know right off the bat that this answer is going to be positive. Okay, but what this would be is like repeatedly subtracting a negative. So this would be minus 3.5 minus negative 3.5, excuse me. And when you do that, what do you get? You end up with 3.5 plus 3.5, right? Which is 7. Subtracting a negative is the same as adding a positive. Now, if you take a look at what they did, all right, they looked at it a little bit differently. They said, we're going to do this problem, and then we're going to take the opposite of that, which is another way to look at it. So the problem they actually did was this one, which we just did previously, right? They got negative 7, and then they went ahead and put that negative. So this is what they had. They got an answer of negative 7, and then they did the opposite of negative 7 and got positive 7. All right? So if you were doing it my way, we can't actually do it because the number line doesn't go that way. But we would go 3.5 that way, and then we would go 3.5 more that way. All right? And then we'd end up at 7. But either way works. All right? Repeatedly subtracting a negative or multiplying by the positive and then taking the opposite of it. Okay? So if we took a look at this one right here, negative 3 times negative 1.25, well, if we were doing it my way, this is what we would do. We would go minus that way, and minus that way. And subtracting a negative is the same as adding a positive, so what we would end up with was 1.25 plus 1.25 plus 1.25, which is going to be 3.75. So doing it my way, we would go 1.25 plus another 1.25 plus another 1.25, and we would end up that way. All right, and we would end up, excuse me, we'd end up right here at 3.75. Now, if we did it the book's way, again, this is what they're saying to do. They're saying to do this. Go ahead and do 3 negative 1.25s. So they would have us go 1.25. Why does that keep ending up in the way, right? And then 1.25 right there, right? And then do it again, 1.25 right there. And they would have us end up at negative 3.75. But then they would have us take the opposite of that, which is going to swing us all the way over to positive 3.75, okay? But what you really need to focus on, guys, is a negative times a negative is a positive, whether you look at it my way or whether you look at it the book's way. A negative times a negative is a positive, so you could just multiply the absolute values and then get the sign right on there. But they do want us to be able to show it on a number line. Okay, now like we said, if you have more than 2 rational numbers, you got to look at how many factors you have. All right, we have 3 factors here. We have a negative times a negative times a negative. Well, if we use our rule, since it's odd, right, we know that the answer is supposed to be negative. If you didn't even know the rule, though, but you knew for 2, you could say, okay, well, this negative times this negative is going to be a positive, and then a positive times a negative is going to give me a negative. Okay, so however you want to go about it, a negative times a negative times a negative is going to be a negative. All right, now let's talk about multiplying fractions. Now remember, when you are multiplying fractions, you multiply the numerators and you multiply the denominators, and then you simplify, or you simplify first and then multiply the numerators and denominators. So if we did it the multiplication way, we'd have 2 times 1 times 3 over 3 times 2 times 5, and we would get 6 over 30, right? And then we'd say, okay, but I can simplify that. What goes into both of those? Well, 6 goes into both of those. 6 divided by 6 is 1, and 30 divided by 6 is 5, and I get 1/5. But if you think about it, it's kind of silly, because what did we do? We multiplied just so we could turn around and what? Divide. So what we usually do instead is we try to simplify the factors instead of simplifying the product. Simplify the factors instead of simplifying the product, okay? So when I look here, I have this 2 on the top and that 2 on the bottom. We know that 2 divided by 2 is 1. And I've got that 3 there and that 3 there, and we know 3 divided by 3 is 1, right? So we call it canceling, but really what we're doing is we're just dividing, right? 2 divided by 2 is 1. 3 divided by 3 is 1. And what am I left with on the top? Well, if you take a look at what I have left on the top, the number that is not canceled off is 1. And what do I have left on the bottom? It's 5, okay? So that is simplifying the factors. This process here was simplifying the product. Both work, but simplifying the factors tends to eliminate mistakes at the end, because sometimes students aren't able to simplify correctly. But if done correctly, both ways work. Okay, so let's take a look at these problems right here, and I'm going to model the simplifying the factors approach, because these problems, they have set up that way, so they're nice. Okay, so here I have a 4 on the bottom and a 4 there. 4 divided by 4 is 1. Right here I have a 3 on the top and a 3 on the bottom. 3 divided by 3 is 1. So if we take a look at negative times a negative times a negative is going to be a negative because it's odd, right? What is left on the top? A 2. What is left on the bottom? A 7. So our answer is 2 over 7. All right, how about this one down here, number 6, okay? Now, if I'm looking on this one, none of the numbers are actually the same. So you might be thinking, well, we can't do it. But of course we can, because remember, we're dividing. Well, 3 goes into 3 once, 3 goes into 9 3 times, right? 2 goes into 2 once, 2 goes into 10 5 times. And hey, look what I have now here. Now I have a 5 here and a 5 here. Oh, wait, there's more, because I have a 3 here and a 6 here. Well, 3 goes into 3 once, 3 goes into 6 twice, and look at that. What do I have left on the top? A 1, a 1. I should have written it here. Well, I don't usually write the ones when they cancel out the same. And on the bottom, I have just a 2. So all that simplifies to 1/2. Now let's look at the signs. Let me erase real quick here. We had a positive times a negative times a negative. We had an odd number of negatives, so the answer is negative. All right? So again, simplifying the factors is usually easier than simplifying the product. If we had done this the other way, let's see, we would have gotten 90 on the top, and on the bottom we would have gotten 180. Of course, that one you could probably see pretty clearly is negative 1/2. That wouldn't have been too bad if we simplified the product, sorry, not the factors. Okay? All right, so that is working with fractions. All right, let's do a few with well, let's do this one, a couple where we have whole numbers times fractions. All right, if you're given a whole number times a fraction, you simply put the whole number over 1, which now makes it a fraction times a fraction. All right, so again, we would try to simplify the factors. In this case, it wouldn't. We would get negative 10 over 3, and by the way, that's not going to simplify at all. Positive times a negative is a negative, and we just get 10/3. And that answer, it's an improper fraction. It's perfectly fine. There's nothing wrong with that answer. It doesn't simplify. If I did this one, I'm going to get a negative 3 over 4. Again, that does not simplify. This one right here, positive 3 times 4/7, that's going to give me a positive 12/7. By the way, I was not paying close attention. They want us actually to use the number line. So let me show you real quick. 5 negative 2/3. These are divided into 2/3. So there's 1 2/3. There's 2. There's 3. You'll notice I'm going 2 lines over every time. There's 4. And there is 5. And if you see where we end up with, we end up at negative 3 right here and 1/3, which of course would be an acceptable answer. This is the fraction. This is the mixed number, right? If we were to do this one right here, 3 times negative 1/4, it's interesting they gave us fractions, and then here they gave us decimals. So a fourth is half of a half, right? So that would be 1/4. That would be 2/4. And that would be 3/4. So if we were going to give a decimal answer, this would be what right here? Negative 0.75, because that's halfway between negative 0.5 and negative 1. Negative 3/4 is the answer as a fraction. If they give you a fraction problem, you should give a fraction answer. If they give you a decimal problem, you should give a decimal answer. Not quite sure why they mix the two here. All right, again, sevenths. There's one. Let me do this last one as a number line problem. Negative 3 times negative 4/7. Now, if it were me, I would say this is repeated subtraction, so I would do negative, subtract negative 4/7, subtract negative 4/7, subtract negative 4/7, and that's going to move us all positive, right? Positive plus, 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 plus. And we would get 12/7. By the way, 1, 2, 3, 4, that would be 4/7, right? Because these are 1, 2, 3, 4, 5, 6, 7. So these are 7s. So if you're doing it my way, you'd simply go 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. Did I get it right? 1, 2, 3, and right here. And we would end up right here at 12/7, right? Okay. If you were doing it their way, you would make this the opposite of 3 times negative 4/7. So these arrows would go the other way. They would go that way, and then we'd simply flip the answer over. All right? I like my way, repeated subtraction. All right, so back to these right here. These are mostly decimals. Remember, when you're multiplying decimal numbers, you want to do something like this. If we have 3.4 times 2, all right, well, I mean, hopefully this one you would just know. 3.4 times 2 is going to be 6.8. But remember, when you multiply with decimals, the answer you get will have however many decimal places there are afterwards. So this one only had one place after the decimal, so it had one there. All right, and a negative times a negative is a positive. Here we have a negative times a positive, which is going to be a negative, right? So I have 2.4 times 3. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. So I get 7, 2, but there's one decimal, one number after the decimal, so I get negative 7.2. All right. Okay, and we'll do a few word problems, and then we are done with this video. All right, so it says Sandy has $200 in her bank account. If she writes 6 checks for exactly $19.98, what expression describes the change in her bank account? Remember, when you are writing checks, money is coming out of your account. We represent that by a negative. So this would be represented by 6 times negative 19.98. All right? So what is the account? Well, we're going to have to do 200 minus 6 times negative 19.98, right? All right, actually, we're going to do 200 plus, because we already took the negative there. We could also do 200 minus 6 times 19.98, okay? Either one of those would do. Adding a negative is the same as subtracting a positive. All right, so we're going to have to find out what is 19.98 times 6. So here we go. 6 times 8 is 48. Carry the 4. 6 times 9, 54 plus 4 is 8. Carry the 5. 6 times 9, 54. 54 plus 5 is 59. And finally, carry the 5. 6 times 1 is 6, plus 5 is 11. Okay, how many numbers did I have behind the decimal place? 2. All right, so this actually equals negative 1,11988. All right, that is how much money that she spent. All right. By the way, a quick way to do this mentally, this is really close to $20, right? If you do 20 times 6, you get 120, right? $120, but there's 2 cents 6 times, so she actually had 6 cents less, and if you do 6 cents from 120, you get 119.88. All right, what is her account balance? Well, now we actually have to do 200 minus that 119.88. All right, and if we do that, what's going to happen here? We're going to have to borrow, aren't we? So if you take away 88 cents from $1, that's going to give you 12 cents, right? And this is actually then going to be 199, right? Minus 119, and we're going to get $80 and 12 cents, right? $80 and 12 cents. And if we were to add those together, we should get back up to the 200, right? Put that 88 cents with the 12 cents, we have $1. This would give us 199. Tack that dollar on. We're at $200. All righty. How about this one? For home economics class, Sandra, or is it Sandra, has 5 cups of flour. She made 3 batches of cookies that each used 1.5 cups of flour. Write and solve an expression to find the amount of flour Sandra has left after making the 3 batches of cookies. Okay, so this is very similar, except instead of deducting money, we are deducting flour. All right, so she made 3 batches of cookies that were 1.5 cups each. Well, 3 times 1.5 is going to give me 4.5 cups. All right, so we're going to have 5 minus 3 times 1.5, which is 5 minus 4.5, which is 0.5. All right, so she has 0.5, or hopefully you all know that is the same as 1/2 cup left. Okay, 1/2, that's a half. 1/2. All right. Okay, so I think that's what I'm going to end up with in this video. I hope this video was helpful in helping you to understand how to multiply rational numbers and how to solve problems involving rational numbers. Have a great day, everybody. I'll see you next time.